Every 5 minutes, there is somebody who's killed because of snakebite. This is a silent epidemic, but the treatment for this is a 19th century solution which was invented when the time when steam engines were running, and still we are following it. Every year, we are losing nearly 1,50,000 people because of this snakebite, and now scientists have got a breakthrough. There is a super antivenom which has been got from the camel species of llamas who have tiny antibodies which are going to counteract the snake's venom. Hi guys, in today's video, let's speak about this problem of snake bite and why is it a silent epidemic, what is the current treatment and what are the shortcomings in that and what are these nanobodies from these llamas going to do. See, let's first discuss the problem of snake bite and the current treatment options for it. Then only we'll understand what this new discovery is going to do. See, when we think of global health crisis, what do we think? We think of viruses, we think of pandemics. But this snake bite is actually a silent epidemic, and WHO tells that this is a neglected tropical disease. Why is it neglected? Some disease which takes 1,50,000 lives a year. That is, you are having an aeroplane crash every day in a year. That will amount to this much amount of people expiring because of snake bite. The main problem is the snake bites. Where does it happen? It either happens to a farmer in a village in India, or to a kid who's playing in Senegal, or to some guy who's in Uganda. See, what is the common problem between all these three? To reach the hospital on time. See, when it happens in a remote place, the main problem is they have to reach the hospital on time. By the time they reach, if the snake's venom enters into the body, then toxicity occurs. Even if the patient reaches the hospital on time, the availability of antivenom is in question. Okay, antivenom is present, that first the patient has to know which snake bit them, because every antivenom present today is specific for a specific type of snake. But if the snake bites at night and the person doesn't know which snake bit them, then the problem starts. The doctor has to wait for the symptoms to step in, because today snakes can create two types of toxicities. One is the cardiotoxicity, second is the neurotoxicity. And they have to wait for the symptoms to set in, and then only they can give the antivenom. See, this is all a big problem. Even if we give this antivenom, if some disability has occurred before giving this antivenom, that is not reversible. See, mounting 2 and 2 together, we can see that this is a global health crisis which is mainly affecting the rural places of countries, and we are not able to find an effective solution for it. So now let's see what is the current treatment option we have. This is a marvel of the 19th century, invented by a person named Albert, who was a student of Louis Pasteur. See, the first step in this process of creating antivenom is you collect the snakes in that area and you collect their venom. See, usually in Africa, the snakes which are very indigenous to that area, like the mambas, cobras. In India, we can take the Indian crate, the Russell viper. So in some states, there are some snakes which are indigenous to that area. So this antivenom preparation is specific to specific states in India also. Now, first they collect this venom, and then what they do is they dilute it. Now they take small quantities of this venom and they start injecting it into horses over a period of months. Now the horse's immune system will start developing antibodies to this venom, and after a period of months they will collect this blood. Once they collect this blood, they will filter out the plasma and they will take it. This plasma will contain horse proteins as well as this antibodies to snake venom, and then they will filter out the horse proteins also, and this is how these antivenoms are prepared. Now let's see what are the problems in this. The first thing is the whole process is expensive. For this you need herds of horses and lot of labor. That is the first problem. The second problem is the serum sickness. That is, when you create an antivenom from a horse, there is some amount of horse protein present in this venom, and when we inject it into our body, our immune system can detect this horse protein and it can create something which is called as the anaphylactic reaction, which is basically an allergic reaction, our body's reaction to a foreign body. See, this is very dangerous. That is the reason why doctors are often hesitant to give this antivenom when a snake bites a person because of this allergic reaction. See, the third problem is today's antivenoms are not broad spectrum. That is, a single antivenom cannot treat the bite of all the snakes. Every antivenom is specific for a single snake. That is, you collect the venom from the snake and then you dilute it, you put it into the horse, then you take it, you separate the plasma and you create an antivenom for a specific snake bite. That is the reason why doctors are going to ask you when you go with a snake bite to a hospital, which snake bit you. Suppose if we don't see the snake, that is when the problem comes, because giving a wrong antivenom is going to create more harm than good. So the need of a broad spectrum antivenom has been a demand for over a century now. The fourth problem is the problem of the cold chain. That is, these antivenoms need a cold storage facility. See, in cities it is not a problem, in big hospitals it is not a problem. In villages also it is not a problem. Today in PHCs there are a lot of refrigerators where you can store this antivenom. The main problem is the electricity supply. What if there is no proper electric supply to that village and the current goes 6 hours a day? Then this antivenom will become literally ineffective even if you give it to a patient. So these are the main problems. That is the high cost in creating it, the problem of anaphylactic reaction. The third thing is that the specificity of these antivenoms is only for a particular snake, and the problem in transport. So for centuries now, we have been searching for an alternative which could be broad spectrum, easy to transport in such a way that the patient will get a treatment on time and he suffers no allergic reaction for these antivenoms. Since the 1980s, scientists have been observing one thing. See, in our body and body of all mammals, we have something called as the heavy chain antibodies. Let's not go behind the science of it. These heavy chain antibodies are the one which mount an immune response whenever a foreign body enters into your body. Now the main problem is these heavy chain antibodies have 4 protein chains, means that these antibodies are big. So because these antibodies are big, they are not able to travel through the system when we inject them. That is, you collect this antivenom from the horse. This is made up of heavy chain antibodies which have around 4 protein chains. So they are not able to go and search for the venom which is present in the small blood vessels because of its large size. This is when they realized something was odd in the camelid species, that is camels, llamas. In this species, they found this heavy chain antibody to have only 2 protein chains. That is, they are smaller than the regular antibodies which are present in us. Now, another major breakthrough came when they found something present in the tip of these heavy chain antibodies which were called as the nanobodies. These nanobodies are in very simple terms like a motorcycle, and the heavy chain antibodies in our body is like a truck in a road. See, a truck in a road in traffic will go slowly, but a motorcycle can easily go through the small spaces which are present. This is the comparison. I have a video which explains what nanobodies are. Let's play that.
The first difference between nanobodies and traditional antibodies is their size. A nanobody is about 1/10 the size of a conventional antibody, a significant difference that has profound implications. Imagine a house is on fire, and the venom toxins are like arsonists, setting destructive fires in every room. A traditional horse antibody acts like a fire engine. It's big and powerful, fighting the fire from the street to prevent the house from collapsing. This is akin to saving a patient from organ failure, but the antibody is too large to get inside and stop the damage room by room. This inherent limitation explains why traditional antivenom is often ineffective at preventing local tissue damage. In contrast, a nanobody is not a fire engine. It's like a squad of firefighters who can kick down doors and run through every hall and room. Their small size allows nanobodies to escape the bloodstream and rapidly penetrate deep into the body's tissues. This means nanobody antivenom could, in theory, not only prevent death, but also prevent the horrific amputations that plague hundreds of thousands of survivors.
So with this discovery, scientists were thinking something. What if we can use this llama to produce a broad spectrum antivenom? So what they did was, they took venom from different snakes, that is around 18 species which are very specific to Africa, and they created a venom. And they injected this venom into the llama. This llama, what did it do? It produced antibodies. Now they extracted this blood from the llama and they extracted the RNA and they used the Nobel Prize winning technology which is known as the phage display. So what they do in this phage display is, once this antibody is extracted from the llamas, they extract these nanobodies. Now this nanobody is attached to a virus. Now what they do is, they have a filter. In this filter, different snake venoms are there. Now already the llama is injected with this venom and it has produced antibodies, and the nanobodies from that have been extracted and they are attached to virus, and they pass this through this filter, and whichever gets attached to the venom, they extracted it. Finally, they found around 6 different type of nanobodies which are actually the jackpot. That is, these were the ones which were working, and when they put it into test, they found out that this antivenom was able to neutralize 17 of the 18 snake species venom which they had injected in llama before. That is, this llama has produced a single antivenom which is able to act against 17 of the 18 snakes. Now you have a broad spectrum antivenom. Now they put it into field test. They tried it on mice. This, when injected into mice, after this venom which was injected into the mice, this antivenom was able to prevent death in 6 of the 11 mice, and in the other 5 mice also it delayed the death. Now the question comes, with this experiment successful, have we found a broad spectrum antivenom? And the answer to our questions. So these antivenoms, which are made from nanobodies, have a lot of advantages compared to the traditional antivenoms. The first advantage is the serum sickness. That is the anaphylactic reaction which develops with these traditional antivenoms when you give them, because the horse proteins can be detected by the body and an allergic reaction can be mounted against it. But this antivenom, which is made from the nanobodies from llama, what it does is, it is highly purified and the chance of allergic reaction is less. Now let's put it into test in a real world scenario. See, a doctor is there and a patient comes with snake bite. Now the doctor is very worried of giving an antivenom thinking of this anaphylactic reaction. But this new broad spectrum antivenom has very less chances of anaphylactic reaction compared to that of the traditional antivenom. Now he will not be hesitant. Now he will give this antivenom also. This one problem is solved. Now the second problem is the problem of permanent disability. See, when a snake bites you, the venom enters into your body, we give antivenom and we save your life. But what happens to the local damage? Suppose a flesh-eating snake comes and bites you and leaves a permanent disability in your foot which requires amputation. The problem with the traditional antivenoms is they are made up of these heavy chain antibodies which have 4 protein chains. So these are big, think of it like a truck. So they are able to enter your bloodstream and counteract the antivenom and prevent us from dying. But it does not prevent the damage which happens to the peripheries, that is the damage which is happening in the small blood vessels. So this will be counteracted by these nanobodies because they are very small and they can enter the bloodstream like a motorcycle, and they can go till the peripheral arteriole and strike this antivenom and prevent this permanent disability also. The second problem is solved. The third thing is the transport. That is, the traditional antivenoms need cold chain for transport. But these nanobodies are highly stable and they don't need refrigeration. Now this is a potential breakthrough because the main problem is these snake bites are happening in villages, and the PHCs and the clinics which are there in different countries in these villages are all having this antivenom in a refrigerator. The problem is not having a refrigerator, but the electricity supply to this refrigerator. Suppose current goes for 12 hours in that village, then this antivenom gets useless. But with these nanobodies, this will not need refrigeration, so just they can keep it in their backpack, and anywhere snake bite happens, they can go there and give this antivenom. This is a game changer. See, the ultimate goal is to create something like an EpiPen. That is, you can just have a pen which has the antivenom. And since it is broad spectrum, any snake which bites, you can just inject this antivenom and your life will be saved. So that is the ultimate goal. So the problems of serum sickness, permanent disability, cold chain are all sorted out. And also the major other problem in traditional antivenom is the cost. You need a horse herd, you need labor for that. All that is circumvented by this. You can shift the production to a bioreactor. See, these are all the advantages on paper, and only when we put it for production in mass scale, we'll come to know whether it is feasible. See, right now, human trials have not been started. First, they will start a phase 1 trial to test for the safety. The phase 2 will be to test this effectiveness against a select group of snakebite patients, and the third phase will be the most important because they will compare this nanobody driven antivenom against the traditional antivenom to find out which is better. All this is years away, but this technology is going to be a game changer if it is produced properly and it is manufactured correctly. See, till today, a 21st century problem is being treated with a 19th century solution. But this new discovery is going to be a game changer, and the ultimate goal will be to make sure that this nanobody driven antivenom, which is broad spectrum, that is, it can treat any snake bite in that region. That is, suppose in India you have some 50 snakes which are the most common. You can make a common antivenom for all these 50 snakes. Right now there are different antivenoms for different snakes. Now you can just make a single antivenom and distribute it everywhere. And everywhere you see a snake bite, you don't need to wait for the doctor to ask you which snake it was. You can just immediately put this antivenom and the life can be saved. This is potentially a game changer, but we need to do human trials. We need to check the feasibility of mass production. All this is going to happen in the near future, and let's hope that everything goes to plan and we get this new broad spectrum antivenom. Do like, share and subscribe me for more interesting videos.